So, good morning, everyone. Let us start with our today's class. I hope everyone is audible. Is my audio clear, everyone? I guess all of you can see the screen.
Yes, sir.
Okay, चलो शुरू करते हैं. So, in the last class we discussed about introduction to dynamics, right? What is dynamics and everything. So now today, basically what we are going to discuss is let us revise the Newton's third law of motion. Okay. So what is Newton's third law of motion actually? So Newton's third law of motion, according to Newton's third law of motion, what it states, we this okay, according to Newton's third law of motion, what it states that to every action there is always an equal and opposite reaction, right? So if there is always an equal and opposite reaction to every action, so what do you mean by that? By action, it is meant the force. Okay? So by action, it is meant by what? The force. That means suppose if a force is acting on a body, then that is known as action. The reaction means the equal and opposite force. Now, once you apply force on a body, there will be an equal and opposite force acting on the body, right? So that equal and opposite force that is acting on the body is known as what? Reaction. Okay. So now we discussed these things in the last class also. So first of all, there is one example which is very much evident. It is what? Recoil of a gun. Now suppose if you are firing a bullet, okay, what happens is that you fired a bullet and the bullet goes at a particular speed. Now the bullet reaches a particular speed and then it recoils back, right? If the bullet recoils back, that means what? It is giving a backward push. So as per Newton's law, I mean Newton's third law of motion, what actually it means is that m1 v1 equal to m2 v2, or I can say that mass of bullet multiplied by the velocity of bullet equal to what? Mass of the gun multiplied by the recoil velocity of the gun. So this is how the Newton's law work. Okay. So I guess we did this numerical in the last class. A bullet of mass 20 gram is fired. So do I need to discuss this again, or is it okay with you people? Hello. So do I need to discuss that numerical again, or is it okay with you? Anyone?
It's okay, sir. It's okay.
Okay. Okay. So there is another application of this, which we can say it as motion of a boat. So what motion of a boat actually means? Motion of a boat means what? Suppose you are moving the boat or roll. You are towing the boat, yeah, in one direction, and the boat is moving in one direction, and the water is moving in the opposite direction. That means what? Every action. That means the action is what? Moving of a boat. And equal and opposite reaction means what? The boat is moving forward, and you are rowing the boat in the opposite direction. Since you are giving a reaction in the opposite direction, that is why the boat is moving in the forward direction. This is how it is being done. Hmm. Now let us discuss this next topic, motion on inclined planes. Okay, so what is motion on inclined planes? Motion on inclined plane, this means that the in the previous discussions, what we discussed was that the body is moving in what? In plane. Plane means what? In a flat surface, not an inclined or maybe a surface which is like a bit slanting. Okay, so now we will be discussing bodies which are moving in an inclined plane. So you can see from this figure. Okay, so now if you see this figure, what happens? So now if you see this figure, what happens here is the body was moving initially in a flat surface, but to the contrary, now the body is what? Moving in an inclined surface, right? So now if the body is now moving in an inclined surface, this means what? This means the surface is a bit slanting, right? So if the surface is a bit slanting, then what you can say that here from this figure, if you can see, let me show you. Okay, so in this figure, if you can see, the surface is inclined at an angle what? Alpha. So if the surface is inclined at an angle alpha, then you can say that this is a bit inclined. So look here, this is a bit lift up. Hmm? This is a bit lift up now. If this is lifted up a bit, then the body is moving in an inclined plane. Hmm. Now, when a body is moving in an inclined plane, be it in the upward direction here, look, in this direction, or be it in the what? Downward direction, like this. So, there are the two directions. So, be it in the upward direction or be it in the downward direction, right? The body is moving. Now, what will happen? Now, what will happen? The body, if the body is moving in the upward or downward directions, then we can say that the body is inclined with the horizontal, right? Now, here let us consider this body which is green color. It has a mass of what? M. Hmm. This body has a mass of M, right? If the body has a mass of M, and if alpha is the inclination of the plane, huh? If alpha is the inclination of the plane, then there will be two reactions. Now, first of all, look, the body, it has a center of gravity acting at its centroid. Huh? So if it is acting at its centroid, then there will be one normal reaction. Okay, so there will be one normal reaction, and it is due to the mass of the body. We all know what is mass. So if the normal reaction is due to mass of the body, then the normal reaction, suppose if the body is like this in a flat plane, if the body is like this, then also the normal reaction is perpendicularly downwards, or and the body is inclined. Okay, if the body is inclined also, suppose in this manner. Then also it has one normal, the normal direction coming from it, it is always perpendicularly downward. Okay, so be it in the, what do you call it, be it inclined or be it, what do you call it, parallel to the ground, in both cases we'll be having the normal reaction vertically downwards. So this is the normal reaction of the body. Okay, and after that we are having what? After that we are having the force component, or maybe frictional force component. Now in the frictional force component, if you see, in the frictional force component, if you see, the coefficient of friction is there, which is mu. Now, and there is one expression R. Now just now we discussed the acceleration due to gravity, which is at a perpendicular downwards. Now if you see from this figure, this is g, or mass mg, and there is a normal reaction. So this is the normal reaction actually. This normal reaction will be what? It will be acting perpendicular to the body, and the g will be acting vertically downwards. Now you can write that F equal to mu into R. Now R, we found out what? R equal to mg cos alpha. You have to remember these terms. Okay. So now why mg cos alpha? Someone might ask. So mg cos alpha is because, look, this one is plane. Okay, so this one is plane. So we have to draw like this. Now there is an inclined surface here. There is an inclined surface. The body is here. Okay. So now what happens? M is like this. R is like this. Right. Now if R is like this, then as per Newton's law, there will be an opposing force here. So right, this one is opposing force. Now we can write this M, this is alpha, right? This angle, that small angle, that small angle between these two, that means this one, this is alpha. So this angle, this is also what, alpha. Remember, it is a basic principle. This one is will be also alpha because of geometry. Now if this is alpha, then we can write like this, no? Now this is coming downwards, so this is mg. Why mg? Because acceleration due to gravity. This one, this part. Okay. Now this part. Now this is angle is alpha. Since this angle is alpha, so this one for this part, for this arrow, it will be what? Now this is the cos theta component, mg cos alpha. So this is the cos theta component. So this one will be in this manner. Okay. So if this one will be in this manner, then we can do one thing. It is mg cos alpha. Now we can do what? We can write this one in this manner. R equal to mg cos alpha. Now there is one component, which one is what? F. This. So F is equal to what? Mu into R. Okay. Mu is what? Coefficient of friction. So since force of friction is acting here, so mu is what? Coefficient of friction, and R is the normal reaction. Okay. So if R is the normal reaction, then then what we can say that since R is the normal reaction and mu is the coefficient of friction, we can say that F equal to mu into R. Now look, this mg or this mg part, or that means due to gravitational from the body, if it is arcs. Now if this side is cos theta, then here there will be another component, which is what? Mg sin theta, right? There will be another component, which is mg sin theta, or maybe mg sin alpha. So we'll write like this, mg sin alpha. So if this is what, this component, so now there are two components. For R it is mg cos alpha, and for the other side it is mg sin alpha. Now this component, that means this sine component, is sliding or moving component. That means what, we can write that so what we can write is f equal to what, mu r, or equal to what, mg sin alpha. So this is how it is being written down. Okay. So these are how the two components are taken. Now let us do this numerical. Okay. So what is given in the question? If you see in the question, okay, let me copy this question once. So if you guys can see the question, can you please can you see the question in my screen?
Yes, sir.
Okay, good. So I just explained you how to do. Just try to solve it out. We'll discuss it if you can't. Will you please try it solving? Since you are not, I think so. Just do one thing. Those who are interested in solving this one, just take a screenshot. You'll have to do it of your own, or I'll discuss it in the next one or two classes. Huh? We'll do another one today. Is it okay? Better let me explain. I think so. No one is cooperating. Let me explain it. So now in the question it is given what? A body of mass 200 kg is initially stationary at 15-degree inclined plane. So the inclined plane is what? 15 degree. That means what? Alpha is 15 degree. Okay. Now you have to find out what distance along which the inclined plane must slide before it reaches a speed of 10 meter per second square. We have to find basically what the distance. Okay. Now you have to take the coefficient of friction between the body and the plane as 0.1. So let us give you a brief overview. So first of all, you have to find out what you are given m. You are given the mass m. So this is 200 kg. So this is given 200 kg. Now it is given initially stationary. Initially stationary means u is equal to what? 0. If u is equal to 0, then what happens is that if u is equal to 0, then what happens is that inclination of the plane. That means the body is inclined at an angle what? Alpha equal to 15. That means this one. So the plane is inclined at an angle of alpha equal to 15 degrees. Now it is also given that what what distance along the inclined plane must the body slide before it reaches a speed of 10 meter per second. So what happens is that the final velocity or v is given as well. Okay, so v is given as 10 meter per second. So if v is given as 10 meter per second, then what happens? U is what? 0, v is 10. Now if you see your first principle is what? First of all, you have to draw a free body diagram or FBD. So how will you draw that free body diagram? So for that case, you'll have to do what? You'll have to draw diagrams like this. Okay. So now if you draw diagrams like this, then first of all, you have to find out what? The sin theta component. Why sin alpha component and cos alpha component? Now look. Since the body is coming like this, so there will be one force that is responsible for sliding down the body. Now body is coming like this, so if it is moving in this side, that means what? It is sliding, right? Now what happens? This one is the cos alpha thing, and here it will be what? The sin alpha. Now if the body is sliding down, if the body is coming down like this, then you can say that the body is sliding down. So if the body is sliding down, then you can say that we are having the sin alpha component because of this component. Let me see. Because of this sin only, this is moving in this direction, no? So that is why mg sin alpha. Now we know m, we know g, we know sin alpha. Alpha is 15 degree. So this one we got. Now the normal reaction. Normal reaction means this is r. Now this normal reaction, it is like this, no? So if it is like this, then opposite is what? Cos alpha component. So r is equal to mg cos alpha. Okay. Now force of friction. Now friction is coefficient is given 0.1. Now the frictional force will be what? F equal to mu r. So F is acting in the opposite direction of the motion of the body. Since the body is moving downwards, that is why the frictional force is acting in the opposite direction of motion of the body. Now the frictional force, if it acts in the opposite direction in the motion of the body, that means what? That means sine alpha, this side and this side, if you subtract these two, then you will get what? The net force that is available to move the body. So F is what? Frictional force. One is frictional force and one is the force responsible for sliding. So if you are having these two forces, then if you subtract these two, then you will be having the net available force that is capable of moving the body. So now you can find out the net available force like this. That means if I find out this one, that is sliding, force responsible for sliding, then you find out the normal direction. And always remember frictional force equal to coefficient of friction mu into normal direction r. Now if you subtract these two, then you will be getting what? The net force that is available for moving the body. Is it over? Now once you get the net force, F equal to what? Ma. This is F. So Ma. This is F equal to what? Ma. That means what? You know the mass, so you can find out the A. A means what? Acceleration. Now you just put this acceleration in this equation. V square equal to U square plus twice AS. Now U is 0, V is given 10. So you will be getting what? S. So you have to find out what? The distance that is traveled by the body just after sliding. As simple as that. So you just try to solve the numerical now. I'm giving you 5 minutes. Just try to solve the numerical. Since I have explained you properly, so please try to solve the numerical. If anyone is having any doubt in this numerical, ask me. Students, are you trying to solve it, or are you simply connected?
Yes, sir.
Okay, okay, good, good. Okay, good call. So, if anyone got any answer from even the first part, just tell me. How much did you get the F, or maybe something else? So, if you're having any doubt, please let me know. If you don't have any doubt,